So this is day 3 of Trig. We're going to be talking about angles. Sorry. So in this section, we're going to be looking at positive and negative angles, coterminal angles, reference angles, and then using coterminal angles to help us with evaluating trig functions. So a little review from geometry. An angle is formed when a ray is rotated around its endpoint. That common endpoint is called the vertex. Okay, so you can see in the picture the vertex. The ray in its original position is called the initial ray or the initial side. So this would be the initial ray. And we talked about when an angle is in standard position. For example, in the unit circle, if we picture the unit circle in the xy plane, all of those angles we're considering to be in standard position, where the initial ray is on the positive x-axis. So in this picture, our initial ray is kind of that bottom directed line segment. And then the terminal ray, where the angle stops or terminates, is going to be this top one. And for this picture, you can't see the direction of the angle, but let's say that the angle was rotated or created from rotating that terminal ray in the counterclockwise direction. And whenever an angle is rotated in the counterclockwise direction, that creates a positive angle. So all of the angles that are on the unit circle are positive, and we can think about them rotating from the positive x-axis in the counterclockwise direction, creating a positive angle. If we think about the terminal side having been rotated in the clockwise direction, that creates a negative angle. Okay, so counterclockwise direction creates positive angle. Rotating in the clockwise direction creates a negative angle. So it's going to help us to kind of have an awareness of what angles would look like or where they would terminate in the xy plane. We know that 360 degrees is a full rotation, which is equivalent in radians to 2 pi. Half a rotation is 180 degrees or pi in radians. Quarter rotation is pi over 2 or 90 degrees. So let's determine where each of these angles terminates in the xy plane, like in which quadrant, or if not a quadrant, along which axis each of these angles terminates. And it's going to be helpful for us for now to sketch a picture, but you could also just visualize in your head to determine where each of these angles terminates. 400 degrees is over one rotation. Since 360 degrees is a full rotation and 400 degrees would just be 40 degrees more than that full rotation, we know that 400 degrees is going to end up terminating in quadrant 1. In the same place that 40 degrees would terminate. So if this is the initial ray along the positive x-axis, as we're thinking about this angle being in standard position, so starting along the positive x-axis, it would rotate and it would go past that full rotation and then terminate in the same place as 40 degrees. So in quadrant 1. Now negative 150 degrees, since it's a negative angle, that means that it's rotating in the clockwise direction. Sorry, I had to think about that for a sec. So let's again think about the angle being in standard position. So it starts on the positive x-axis, and then if it's rotating in the clockwise direction, we know that negative 180 degrees would end up terminating in the same place as 180 degrees. So negative 150 degrees will actually end up terminating in the same place as 210 degrees in quadrant 3. It rotates in the clockwise direction. 7 pi over 12, well, that's not an angle that's on the unit circle. Neither was 400, but 7 pi over 12 is in radians. There's no degree symbol, so that's how I know that it's in radians. And for determining where 7 pi over 12 terminates, I know that pi over 2 can also be written as 6 pi over 12. And I know that pi could also be written as 12 pi over 12. So 7 pi over 12 is going to lie between 6 pi over 12 and 12 pi over 12. So that means that 7 pi over 12 is going to need to terminate in quadrant 2. And then negative pi over 2, negative angle, so rotating in the clockwise direction. Okay, so negative pi over 2 is actually going to terminate along the negative y-axis. Which is the same place that 3 pi over 2 terminates. Okay. Now we've kind of already been referencing some coterminal angles. Every angle has infinitely many coterminal angles. And coterminal angles are just angles that terminate in the same place. So they end in the same place. For example, with the angles that we were talking about up here, like 40 degrees and 400 degrees would end up being coterminal angles. They terminate in the same position. Negative 150 degrees and 210 degrees are coterminal angles. Negative pi over 2 and 3 pi over 2 are coterminal angles because they terminate in the same place. So, two angle measures must differ by a multiple of positive or negative 360 degrees or positive or negative plus or minus 2 pi in order to be coterminal. So I'll draw another example of coterminal angles. Why don't we do so this is the x-axis and y-axis. I'm going to draw, how about 60 degrees? This is just a sketch. So now 60 degrees has infinitely many coterminal angles. Like if I were to subtract 360 degrees from 60 degrees, that would give me negative 300 degrees, right? So rotating in the clockwise direction, if I'm subtracting 360 degrees, that would be negative 300 degrees. Or we could think about adding 360 degrees. So that would put us at 420 degrees. So if we started the positive x-axis, rotated all the way around, and then kept going. That would put us at 420 degrees. So those three angles are all coterminal, meaning that they terminate in the same place. Now, the cool thing about coterminal angles is because they terminate in the same place, their ratios for sine, cosine, tangent, and any of their reciprocals are going to be the same, because the ratios for x, y, and r would end up being the same since they terminate in the same place. So the way that this is useful to us is, like, say that we wanted to determine what the cosine of 420 degrees is. Well, 420 degrees isn't an angle that's on the unit circle. However, 60 degrees is an angle that's on the unit circle. So since 60 degrees is coterminal with 420 degrees, the way that we can evaluate cosine of 420 degrees exactly is by thinking about evaluating cosine of 60 degrees exactly, which cosine of 60 degrees, you guys know, is 1/2. Or if we wanted to evaluate cosine of negative, or let's pick another one. How about like sine of negative 300 degrees? Negative 300 degrees is not on our unit circle, but we know that 60 degrees is. So we could think about evaluating sine of 60 degrees, which would end up being root 3/2. Okay, so that's kind of how we can think about using coterminal angles now. Now, to find the measure of the smallest non-negative coterminal angle, which will be the most useful for us, like every angle has infinitely many coterminal angles, but it's going to be useful for us usually to find the smallest non-negative coterminal angle. So basically the angle that's between 0 and 360 degrees, or between 0 and 2 pi if you're in radians. So to do that, if you're given an angle that's positive, you would subtract 360 degrees repeatedly until you have the angle. So basically, if you have an angle that's more than one rotation, you keep subtracting 360 degrees until you get an angle that is between 0 and 360 degrees. And if you have an angle that's negative, then you're going to keep adding 360 degrees until you have an angle that's between 0 and 360. And kind of the same thought process, if you have an angle that's over 2 pi, so more than one rotation, you keep subtracting 2 pi. Or if you have an angle that's less than a rotation, so a negative angle, you're going to keep adding 2 pi until you get an angle between 0 and 2 pi. So let's go ahead and find the coterminal angles, the smallest possible positive coterminal angles, so between 0 and 360 or 0 and 2 pi for each of these angles. So for 900 degrees, if we subtract 360 degrees, we're still going to have an angle that's more than one rotation. So why don't we subtract 2 full rotations? So 2 times 360 degrees, which is 720 degrees. And when we subtract 720 degrees, we get 180 degrees. So 900 degrees and 180 degrees actually terminate in the same place. To find the coterminal angle with negative 430 degrees, if we add 360, we're still going to be in the negatives. So why don't we also add 2 times 360 degrees, which is the same as adding 720 degrees, and that's going to put us at 290 degrees. And negative 13 pi over 6, well, if we add 2 pi, which 12 pi over 6 is equal to 2 pi, that's still, we're going to still be at negative pi over 6. So we're going to actually need to add 4 pi, so 2 rotations, which is equal to 24 pi over 6. And then that puts us at 11 pi over 6. So visually, you guys know 11 pi over 6. Kind of like that. Okay, so negative 13 pi over 6. Would go around 1 rotation, and then it goes around another rotation in the clockwise direction to terminate there. So that would be negative 13 pi over 6. Oh no, that was silly. Sorry. No, that was wrong. So it would actually go 1 full, because negative 12 pi over 6 would be negative 2 pi. So it would go 1 full rotation and then just slightly pass. Sorry, that would be negative 13 pi over 6. But both those angles terminate in the same position. So if we wanted to evaluate tangent of negative 13 pi over 6, we could find the coterminal angle, which would be 11 pi over 6. 11 pi over 6 does lie on the unit circle. So then tangent of 11 pi over 6 would be root 3 over 3. Sorry, negative root 3 over 3. All right, reference angles. So for evaluating the trig functions, I don't think you can use reference angles, but I think it's easier, or it makes more sense, it's more efficient to use coterminal angles. Reference angles are going to come up again when we're studying vectors. It's just important that you know what a reference angle is. It might come up on some sort of standardized test. But the reference angle of an angle that's in standard position is the positive acute angle between the horizontal axis and the terminal side. So this is important. A reference angle is a positive acute angle. So it is an angle from quadrant 1, an angle that's less than 90 degrees. And it's created between the horizontal axis, which is the x-axis, and the terminating side of the angle. So I'm going to draw a picture that represents a reference angle for an angle in either or in any of the quadrants. So if we have an angle, there's 4 quadrants. I'm going to draw 4 pictures here. Let me just copy and paste these actually. This is our x-axis and our y-axis. Oh. Okay. So if we have an angle in quadrant 1 that terminates in quadrant 1, so let's say this is our angle theta. then our reference angle, I'm going to call our reference angle theta ref, is going to be the angle, the positive acute angle that's between the horizontal axis and the terminating side. So guess what? In quadrant 1, our reference angle is the same as our actual angle. Okay. In quadrant 2, if we have an angle that terminates in quadrant 2. So we draw an angle that terminates in quadrant 2. Okay, there's our angle theta in standard position. The reference angle is going to be the angle that's created with the horizontal axis and the terminating side of the angle. So that would be this angle right here. And it has to be a positive angle, so you're thinking about it rotating in the counterclockwise position. This would be theta ref, which is a positive acute angle between the horizontal and the terminating side. An angle that terminates in quadrant 3. Okay, so in quadrant 3, the reference angle would come off of the horizontal axis towards the terminating side. So this would end up being theta ref. Oops, I forgot to label theta. And in quadrant 4, if that's theta, this would be our theta ref. Okay, it must be a positive acute angle between the terminating side and the horizontal axis. All right, so let's find the reference angles for the angles that are given here. All right, so 150 degrees. 150 degrees terminates in quadrant 2. You can draw it. This is going to be theta ref. To find theta ref in this case, you can either just by inspection see, okay, well, that angle is going to end up being 30 degrees, or you can think about it, that's 180 degrees minus 150 degrees to give us 30 degrees as the reference angle. It has to be an angle, an acute angle, meaning an angle from quadrant 1. So there's our reference angle. All right, now we're in quadrant 3 for 255 degrees. So this is going to be our reference angle. And we can think about, to find what that angle measurement is, we could think about subtracting 180 degrees from 255 degrees. So our reference angle ends up being 75 degrees. All right, 7 pi over 3 is over a full rotation, terminates in quadrant 1. So this angle is going to be our reference angle, which that angle you can see by inspection. So 6 pi over 3 is 2 pi. That's a full rotation. So if we did 7 pi over 3 minus 6 pi over 3, that gives us pi over 3. So that angle is pi over 3. And now we have a negative angle. but that negative angle terminates in quadrant 3. That's going to be the reference angle in quadrant 3. So you can see that that angle is going to be pi over 4. All right, so for finding the reference angles for these angles, I think it helps to draw a picture. You might not need to. So negative 315 degrees, that is a negative angle, so it's rotating in the clockwise direction, and it's going to terminate in quadrant 1. Meaning our reference angle is going to end up being 45 degrees. Ooh. All right, 8 pi over 3. 6 pi over 3 would be a full rotation. So 8 pi over 3 is going to go 2 pi over 3 past. So that means we'd have our full rotation, and we keep going to terminate in the same place that 2 pi over 3 does. So our reference angle, since the angle terminates in quadrant 2, is going to be pi over 3. Now, reference angles can help you with evaluating the trig functions. It's just you need to be careful. You have to take into account what the sine is. So remember, all students take calculus. You have to take into account. So since the reference angle is always a positive acute angle from quadrant 1, and all of the trig functions are positive in quadrant 1, you have to take into account where the angle terminates, like the actual angle that you're trying to evaluate the trig function at, where that terminates, and what the sine is of the trig function in that quadrant. For example, for 8 pi over 3, like if you wanted to determine what the cosine of 8 pi over 3 is, well, in quadrant 2, cosine is negative, remember, since the x-coordinate is negative in quadrant 2. So cosine of 8 pi over 3 is going to be a negative value. If we were to use the reference angle to evaluate the trig function, so to evaluate cosine at 8 pi over 3, we think, okay, well, cosine of pi over 3 is 1/2. However, in quadrant 2, it's negative. So it's really negative cosine of pi over 3 is what cosine of 8 pi over 3 is equal to, so it's equal to negative 1/2. So it's just, to me, it's extra thought. I think it's easier to just determine what the coterminal angle is between 0 and 360 degrees, or between 0 and 2 pi, to help you with evaluating the trig functions. Like we could, 2 pi over 3 is coterminal with 8 pi over 3. So you could also just think about what cosine of 2 pi over 3 is, right? That's going to be equal to negative 1/2 as well. So I think it makes more sense, although it is important to know what a reference angle is and how to find it. All right, so we're going to evaluate the trig functions by finding the coterminal angle or the reference angle. Like I said, let's just think about finding the coterminal angle. It's a lot more efficient. All right, so to find sine of negative 480 degrees, and you should show your work the same way that I am. Negative 480 degrees is negative angle. If we add 360, we're still in the negative. So let's add 2 times 360, which is adding 720 degrees. So sine of 240 degrees, well, 240 degrees is on the unit circle, and that's equal to negative root 3 over 2. All right, 23 pi over 6. If we subtract 2 pi, which is the same as 12 pi over 6, that's going to put us at 11 pi over 6. And cosine of 11 pi over 6 is root 3 over 2. Secant of 900 degrees. If we subtract 360, that's not enough, so let's subtract 720. Secant of 180 degrees, that would be the reciprocal of cosine. Cosine is negative 1, so the reciprocal is still negative 1. And then let's add, let's see, if we add 6 pi over 3, we're still in the negative, so let's add 4 pi, which can be written as 12 pi over 3. And that puts us at 2 pi over 3. We know that cosecant is the reciprocal of sine. Sine of 2 pi over 3 is root 3 over 2. So the reciprocal would be 2 over root 3. And then if we rationalize the denominator by multiplying by root 3 over 3, we'll get 2 root 3 over 3. Okay, so that's how we can use coterminal angles to help us with evaluating trig functions at angles that are maybe more than a full rotation in the positive direction, or negative angles, but where the coterminal angle still lies on the unit circle, so that we can evaluate exactly.